Hello, Professor Sargent here with you again for another Math 101 flipped classroom lesson. This is on section 7.6, which is covering solving equations with radicals, i.e. radical equations. It's worth pointing out from page 503 that if both sides of an equation are raised to the same power, all solutions of the original equation are also solutions to the new equation. However, sometimes it is difficult to raise both sides to the same power and do it properly. So, as we see on the next page, page 504, first of all, if the radical, whether it be a square root, a cube root, whatever, we have to isolate it first before we raise both sides to the same power. Now, what power would we use? We would use whatever the index is. We're assuming here that we have the same index on each radical if more than one radical is showing up. Then you're going to get a new type of equation. It'll be either linear, where x is only to the first, or you could get a quadratic equation where you see an x squared in there. However, we will see sometimes the solutions to the new equations are not solutions to the original equation. All of the solutions to the original equation would be included in a solution to the new equation, but not necessarily vice versa. We're going to see in number 2 here how we have to worry about checking, and in number 3 how we have to worry about isolating first. So here we go. This first one, the square root is already isolated because that has an index of 2. Then squaring both sides, on the left side is going to cancel this out. And 25 squared is 625. Add the 1 to both sides. When you check, we want to see if, according to the order of operations, we would subtract first, then take the square root. That's the principal or positive square root. So we do get 25, and that is our solution. However, on the second one, this is not isolated, so I'm going to have to subtract 9 from both sides. Right off the bat, that should be a signal that there's a problem, because this doesn't have a negative in front of it. We should be thinking maybe there's not a solution. Suppose you don't catch that and you square both sides. Then the square root and the square will cancel. Remember, anything that is a real number, when you square it, is going to be non-negative. That's -9 times -9. We get positive 81 there. And when we subtract 4 from both sides, we get x is 77. But when we check, we'll have 81 under the square root. That is asking for the positive or principal square root, which is positive 9. That's not equal to -9. That answer doesn't check. That was our only option. We have to reject it and state there are no solutions. On this third one, you could subtract 25 from both sides to isolate the radical. Actually, it is not isolated yet. It's still multiplied by -1. So that negative over there is not a problem unless we really have this isolated. Divide both sides by -1. We have x minus 6 under the square root equals positive 25. Square both sides is going to cancel the square root. And we already saw back here that that was 625. Add the 6 to both sides. X equals 631. So when we check this, remember, because taking a square root is the same as raising to the 1/2 power, we would have to work on what's inside the parentheses first. So here, find out what's under the root first. Oh, that was 631. Okay, 631 minus 6 is 625. Its square root is 25. So 25 minus 25 does equal 0. That answer does check out. On this fourth one, we have 2 square roots. However, both of them are isolated, so that's still a good thing. There's nothing added or subtracted or multiplied outside of that root. Same thing goes with this one. So we can square both sides right away. And that's going to cancel out the square root on each side. Back here, I wrote that I was squaring it before I wrote that it had canceled. Now in these last two, I'm combining a little bit. Combine the y's. Combine the constants. They were on opposite sides, so I subtracted 5y, and then I subtracted 8. Checking here, 6 times 1 plus 8 is 6 plus 8, or square root of 14, whatever that might be. And on this side, 5 times 1 plus 9, order of operations, multiply it first. That also adds up to 14 under a square root. We don't need to worry about what square root of 14 simplifies to, if anything. We don't need to know a decimal approximation, just that we're getting the same thing on both sides. So because we do, the answer checks, and y is equal to 1. More in a moment. Here's 2 more similar to that. Unfortunately, we're not going to be able to isolate this square root, because if we do, we'd have to divide by 5, which would mean that this one is not isolated. So the good thing is that that's multiplication, and if I square both sides, on the one hand, it cancels out on the left-hand side, the squaring and the square root. Whereas here, because that's multiplication, or if it had been division, I could square the 5 and square the square root of x. So that's going to give me 25x on the right-hand side. Subtracting 26x from both sides, I get negative 20 equals negative 1x. Divide both sides by negative 1, and I get that x is equal to 20. Don't forget to check. 26 times 20 is 520. Subtract 20 from that, and we get 500 under the square root. Because we want to compare, you could put this into a calculator and find out that that is approximately equal to 22.36 something. Then you can do the same thing for the other side. However, if I observe that 100 is a perfect square that goes into 500, and the other factor, 5, is only having 1 as the largest perfect square factor to go into the 5, that's the best split up I could do. Apply the product rule. Take the square root of the 100, to get 10 square root of 5. Compare that to putting 20 for x on the right-hand side. 5 also goes into 20 4 times. 4 is the largest perfect square that will go into 20 without remainder. And 5, we can't get any perfect square out of that besides 1. So apply the product rule there. 5 times 2 out in front of the square root of 5. And we get 10 square root of 5 there also. Plugging 20 in to the original equation and comparing, we get 10 square root of 5, or as a decimal, about 22.36. Either way, we are finding out that x equals 20 does check. On number 6, the square root is already isolated. So square both sides. It'll cancel the square root on the left. And now we have x squared on the right. Combining like terms, the x squareds are going to cancel out. I'll subtract x squared from both sides to get 2x minus 4 equals 0. Add 4 to both sides and divide both sides by 2. Let's see if that checks out. Is also equal to 2 when we plug 2 in for x. So here we go. This is the question. Does that equal the 2 that we'd get on the right-hand side? So order of operations, we'd have to do the exponents first, then multiply. Square root of 8 minus 4, square root of 4. That's asking for principal, a positive square root, which will give us 2, and that's what we wanted. So x equals 2 does check. Here we have a square root that is already isolated, so we can go straight into squaring both sides. Remember, you can combine the following 2 steps. The squaring and the square root will cancel. On the right-hand side, though, a little more work is needed. We just talked about in class squaring a binomial, and there's a special formula for that. I'm going to do this by FOIL just so we can compare. For the first, we would have x times x is x squared. Outers, we'd have a plus 1x. Inners, we'd have a plus 1x. And the last, positive 1 times positive 1 is positive 1. We get to combine those 2 middle terms. They're like terms. That's x squared plus 2x plus 1. The shortcut would have been to square both the x and the 1, but then not forget that you take the product of those 2 and double it. Add that inside. That's using this formula. I took a to be x and b to be 1. X times 1 is x, double that, and we've got 2x. By the way, really you only need one formula, because if b was negative, squaring it, we'd still see a positive here, but a negative for b would result in that being a different sign in between. But you could memorize the second formula, FOIL this out to check that the quantity a minus b squared would give you a squared minus 2ab plus b squared. So whatever way we get what the quantity x plus 1 squared is, it's supposed to be x squared plus that 2x plus 1. Now I'm going to combine like terms. There's no other x squared. I'm going to add 2x to both sides to get x squared plus 4x and subtract 6 from both sides. because that's a 1x squared, to factor to solve that quadratic equation. Another option would be the quadratic formula if you're remembering it exactly. But here I know I need x times x to get 1x squared. So I'd be looking for two numbers with a product of -5 and adds up to +4. Because it's negative, I'm going to need different signs, but the one with a larger absolute value has to be positive to add up to +4. So that's going to be x plus 5 for one of the factors and x minus 1 for the other factor. If you multiply that back out on the left side, you'll be back to this part on the left side. The point of the factoring is that if we multiply two factors and get 0, then one of those factors has to be 0. So either x equals 1 or x equals -5. We need to check this as well. Remember, whatever the solutions to this are, either it's this or it's some part of this. We want to see if both of those work. On the left side, if I check x equals 1, 6 minus 2 times 1 is 6 minus 2, that's 4. Square root of 4 is 2. And on the right-hand side, plugging in 1 for x, 1 plus 1 is also 2. So this checks. That solution is good. Now check x equals -5. 6 minus 2 times -5, take the square root of all of that. We're going to have 6 plus 10, so square root of 16, which is 4. Whereas when we plug it in on the right-hand side, we get -5 plus 1 is -4. Those are not the same. So x equals -5 does not check. Make it clear what you've rejected and what, if anything, is being kept. Our only solution that checks is x equals 1. And this is a garbage or extraneous solution. In a case like this, you could have both check. You could have just one check and not the other. Or you could have to reject both of them so that there are no solutions. On this one, first of all, we have a fourth root, not a square root, and it is not isolated. We subtract 2 from both sides to isolate the roots. Because of the index being even and a negative over here, with no negative in front of this, then we should have a signal that there is no solution. But just like with the second example, just in case you don't spot it, raise both sides to the 4th power. Cancel out the 4th root on the left side. You just have y minus 3. An even number of copies, 4 copies of multiplying -2 is going to give me a positive 16. So when I add 3 to both sides, I get y equals 19. But when I go back in to check, yes, 19 minus 3 is 16. The 4th root is, we're not taking the square root, we're taking the square root again, in other words. 4th root is the square root of a square root. We saw that in class. That's going to be positive 2 because there's no negative in front of that. Because that's a positive 2 plus a positive 2, we get 4 instead of 0. If it had been -2 plus 2, things would have checked out. But we had the principal 4th root. So we have to reject this. Since it was our only choice, there are no solutions. The next step up from solving equations is rewriting formulas. they could phrase this as saying, solve this formula for L. Right now, it's solved for C. We've got one C to the first isolated. I want one L to the first isolated. So I could apply that power rule. Since that's a square root, I could square both sides, canceling it out. The square root on the right-hand side. The next thing that might be bothersome is the fraction. So I can multiply both sides by F to get rid of that. And now when we look at this, all that's happening to L still is it's multiplied by 8. So divide both sides by 8. And now we have L alone. It's truly isolated because its coefficient is 1 and its power is 1. So we have rewritten the formula so that L is isolated, i.e. we solved it for L. And that's all I've got for you for now. Hope that helps, and I'll see you in class.